When solving logarithmic and exponential equations, remember your one-to-one properties and your inverse properties. If the bases are the same, the exponents have to be equal. And likewise, if you need to remove a log base a, take a and raise both sides of the equation to the log base a. For example, if we are asked to solve e to the 6x equals e to the x squared minus 7, we note that we have like bases, and when the bases are the same, the exponents have to be the same. So 6x equals x squared minus 7. Now it's a simple algebraic equation. If I take the 6x to the other side, I will get 0 equals x squared minus 6x minus 7. Factoring the equation, I get x minus 7 and x plus 1 equals 0. So x has to be a positive 7 or a negative 1. Now go back and make sure that that doesn't violate any rules. Can we take e to the 42nd power or e to the negative 6th power? And the answer is yes, so both are valid answers to our equation. In the second example, we have 2 times the quantity 5 to the x plus 3 equals 128. To solve that, we need to isolate the base first. So we'll divide both sides by 2. And 5 to the x plus 3 will be equal to 64. Now, to get rid of, or to isolate our power, we need to get rid of our base. So we're going to use the inverse property and take the log base 5 of 5 to the x plus 3 to isolate that. So log base 5 of 5 to the x plus 3 will be equal to, whatever we do to the left side of the equation has to be done to the right, log base 5 of 64. So we know the log base 5 of 5 to the x plus 3 will reduce to x plus 3. And we know by our change of base formula that the log base 5 of 64, when we plug it into the calculator, will either be the common log of 64 divided by the common log of 5, or the natural log of 64 divided by the natural log of 5. So to get the x by itself, we're going to subtract 3 from both sides. So x will be equal to the natural log of 64 minus the natural log of 5 minus 3. So bringing up our graphing calculator, we're going to take the natural log of 64, be sure to close that parentheses, we'll divide it by the natural log of 5, close that parentheses. We can find the result, or our graphing calculator is smart enough to know that it needs to do the division first before it subtracts the 3. So when we take away 3 from that and ask for the answer, we will get our value, which is negative 0.416 to 3 decimal places. In this next example, we have 2 to the x plus 1 is equal to 16. So how do we get the variable isolated if it is the power of 2? Well, if we can take the log base 2 of 2 to the x plus 1, that will remove the log base 2 of 2 to the and give us just an x plus 1. But if we do that to the left side of the equation, we must do the same to the right. So here, x plus 1 will now be equal to the log base 2 of 16. 2 to what power gets us 16? 4. So taking away 1 from both sides, x has to be 3. And don't let this next equation scare you. It looks suspiciously like a y squared plus 2y minus 8 equals 0. So we can factor that. We would call this e to the x and we need to have factors of 8 that subtract to become 2. So 4 and 2 are our options, and we need the larger one to be the positive value. So that looks a lot better. Now we have two factors that need to be set equal to 0. So e to the x plus 4 equals 0, or e to the x minus 2 equals 0. So if I take the 4 to the other side, e to the x will be a negative 4, or if I bring the negative 2 to the other side, e to the x equals a positive 2. Now, how do we solve that? Well, it'd be nice to be able to get rid of this e so that I have just the power. So let's take the natural log of e to the x. That has to be equal to the natural log of a negative 4, or the natural log of e to the x equals the natural log of 2. Now remember, when we first defined logs, we said that we cannot take the natural log of a number that is less than 0 or equal to 1. Log base x of a was defined when a was greater than 0 and a was not equal to 1. So we can't take this natural log of a negative 4, so this is undefined. But we can evaluate the second part of this. The natural log of e to the x becomes plain old x, and the natural log of 2 is 0.693 to 3 decimal places. For this example, remember that the inverse of the natural log is taking e to the natural log. So e to the natural log of the square root of x plus 1 is the same as e to the 4th power. These nicely go away and we get the square root of x plus 1 equals e to the 4th power. But before we go to the calculator, let's ask ourselves, what else are we going to have to do to isolate the x? If the quantity x plus 1 is under the radical, we're going to square both sides. So x plus 1 is now equal to power to a power we multiply, e to the 8th power. And to isolate x further, we'll subtract 1 from both sides. So x will be equal to e to the 8th minus 1. So we will take e, which is the second of the natural log, and raise it to the 8th power, and then we'll subtract 1 from it, and our answer is approximately equal to 2,979, and 957 thousandths. Finally, let's look at this example. The natural log of x plus the natural log of the quantity x plus 2 is equal to 5. Well, unfortunately, at the moment, we can't just raise e to the ln of x plus e to the ln of x plus 2 equals e to the 5. It doesn't work that way. Remember, you know how to condense equations that involve logarithms. So let's condense this and call this the natural log of, if I'm adding two natural logs, that means that we can condense it by multiplying. X times x plus 2 equals 5. Now that we have a natural log on the left, we can take e and raise it to the natural log, as long as we take e and raise it to the 5th power. So this nicely goes away, and we get x times x plus 2 is equal to e to the 5th, or x squared plus 2x is equal to e to the 5th, which won't be a nice number. So let's bring our graphing calculator over here and see what this is going to look like. So e to the 5th, shift of natural log to the 5th power, is 148 and 413 thousandths. So this is a quadratic equation where x squared plus 2x minus 148, and its trailing decimals, is equal to 0. I don't know how to factor that, so I'm going to go to the quadratic equation. Quadratic equation says x equals negative b plus or minus the square root of b squared minus 4 times a, which is 1, times c all over 2 times a, which is 1 again. So let me teach you a couple of calculator skills here. So we have our number, and we're going to take that times a negative 4. So if it's a negative 148 times a negative 4, we'll get a positive number here. And we're going to take 4 minus that answer. Excuse me, 4 plus that answer. And we want to take the square root of this. So second of x squared gets me the square root. And if we do a second of the negative sign, we'll get our answer. So this number here underneath the radical is 24.447. But again, I'm not going to clear my calculator out here. I'll show you another trick in this calculator. This is a number that we'd like to store. So you can use the store button by saying I want that to go into one of my alphabet variables here. So I'm going to store it into A and press enter. So 24.447 is now stored into our value of a. So when we take a negative 2 plus that 24.447 and divide it by 2, we'll have one of our answers, and negative 2 minus our 24.447 divided by 2 will be our other answer. So negative 2 plus the value that we stored in a, press enter first, divide that by 2. So we need to do the addition first before we divide. And one of our answers is 11.223 to 3 decimal places. And I want negative 2 minus that 24 that we stored in a. So negative 2 minus alpha a equals, divide that answer by 2, and we get our second value. Negative 13.223. Once again, don't forget to ask yourself, are these both valid numbers or valid answers? Can we take the natural log of a positive 11 and some odd change? Of course. Can we take the natural log of a negative 13 and some odd change? Absolutely not. So this is our only solution.